Hi everyone, I wanted to do an example also using the binomial series expansion. I know I talked about it in class and I did a couple of really quick examples, but I noticed that in the homework they really want you to expand. So let's work on this one. So this one is number 11 from your homework. And so we want to expand this as a power series. And so as soon as I see it, like that kind of fits the idea that this is 1 plus x to a power. So this is to the 1/4. So it fits, right, I can rewrite it as 7 times 1 plus x to the negative 1/4. So it looks like a binomial series, which is 1 plus x to the p. And so as soon as I recognize that this is the binomial series, then let's look at the binomial series expansion. And so when you have a function that looks like a binomial, right, 1 plus x to the p, and p, if it's a nice whole number, right, then this is just a polynomial. And writing a function as a Taylor series or as a power series is really writing any function as a polynomial. So like if p was 2, then you can write a function as a quadratic, right? And then in this case, our p is negative 1/4. So p doesn't have to be a whole number. It can be a fraction. It can be a negative number, like in our case. So what does this look like? Well, the binomial series for these we talked about is p choose n times x to the n from n equals 0 to infinity. But what does the expansion look like? In this problem, right, we want to expand. So we're going to say 1 plus x to the p is equal to, when you do this, right, when n is 0, you end up with 1. So we're going to have 1 plus, and then when n is 1, and this, it might be worth mentioning, right, when you have the definition of p choose n, is, what is it? It's p factorial, and this you may or may not remember from your pre-calculus class. It's p factorial over n factorial times p minus n factorial, right? And so that's what this is. So when you're looking at when n is 0, you're having, right, p choose 0 will be then p factorial over 0 factorial times p minus 0 factorial, which we end up with 0 factorial is defined to be 1, right? So you end up with p factorial divided by p factorial, which is 1. So that's how we end up with that 1 there. Okay, then p choose 1, then you're going to go through, pardon me, the same sort of thing. So then you're going to have plus px, and we went over this expansion in class, plus p times p minus 1 x squared over 2 factorial plus p times p minus 1 p minus 2, and we have the 0, the 1, the second degree, and then so this would be x cubed over 3 factorial, and so on. And what's our last term? So the last term was essentially p times p minus 1, p minus 2, dot, 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 p minus, and what was it? N minus 1 times x to the n over n factorial. And then this keeps going. And that's because, notice, right, we talked about it in class. When it's x cubed over 3 factorial, you have p minus 2 as the last term here. When you have x squared, it's p minus 1. So it's always 1 less. So it's when it's n, you're going to have n minus 1. All right, so now back to our problem. So we're trying to expand, what was our function? 7, 1 plus x to the negative 1/4. So we're trying to expand essentially 1 plus x to the negative 1/4, and we have a coefficient of 7. So notice our p is negative 1/4. So when I expand this is going to be equal to then 1, right? So 1 plus px, so p is negative 1/4, and then x plus p, which is negative 1/4, times p minus 1. Negative 1/4 minus 1, x squared over 2 factorial plus negative 1/4, right? P times p minus 1 times p minus 2. And then x cubed over 3 factorial. And can we see a pattern? Well, we probably need to do the math a little bit here. So it'll be 1 minus 1/4 x. And so this will be plus, that is negative times, oh wait, what is this? So this is negative 1/4. Well, this is going to be a negative anyway, but what is it? So here you have negative 1/4 times, what's negative 1/4 minus 1? So that's negative 5/4. And you're multiplying. So what is that? So you're going to have plus 5/4, 5/16 really, right? So let me rewrite that a little better. So I'll keep the negative 1/4 there, and we'll say times negative 5/4 x squared over 2 factorial plus, let's do the same thing here. So negative 1/4, our hope is to be able to see a pattern. So negative 1/4 minus 1, we already saw is negative 5/4. So what about negative 1/4 minus 2? So get a common denominator of 4, so that will be 8. So minus 1 minus 8 is negative 9. So negative 9/4 x cubed over 3 factorial, right? Plus, what's the next one going to be? Do you see a pattern? So the next one, right, is going to be negative 1, negative 5/4, negative 9/4, and then it's going to be minus 1/4 minus 3. So common denominator is 4. So what will that be? Negative 13 over 4. And that'll be x to the 4th over 4 factorial plus dot 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 until you get to the nth one, right? So let's see. So we want to be able to write it in a pattern. So I'm going to have my, let's see, so it's 1 minus 1/4 x plus, what does this look like? So notice when it's x squared, I have 4 squared. So I'm going to have negative 1 times negative 5 over 4 squared times x squared over 2 factorial. Plus, what's the next one look like? When it's x cubed, right, I'm going to have x cubed over 3 factorial. Notice the power on the 4. 4 times 4 times 4 is 4 cubed. What do I have on the top? Minus 1 times minus 5 times minus 9. Plus, and you can kind of then see the pattern. So the question is, what does our nth term look like? And so that is what we want to figure out, what the pattern is. So it's going to be based on this, right? Notice that I have, I'm missing one here. Oh, minus 1/4. It'll be 4 to the 4th. And then, so here for the nth one, we're going to have 4 to the n, x to the n over n factorial. So now the big question is, what goes in the numerator of that one? So notice we have minus 1 times minus 5, and minus 1 times minus 5 times minus 9. And so what is going to be here? So think about that for a second. All right, now that you've had some time to think about it, let's go back to the top, right? So our binomial expansion looks like this. So the nth term is p times p minus 1, p minus 2. And so we're going to focus slightly on this last term, right? Because what that means is that here, so I'm going to focus on this guy. So we're going to have the p, right? So it's our negative 1/4 times, then what did we say, right? P times p minus 1 times p minus 2, which we already found those. P minus 1, p minus 2. So we're going to have the negative 5/4, the negative 5, negative 9/4, and so on, times, times, times. And then p, so negative 1/4 minus n minus 1. And then that's going to be times x to the n over n factorial, right? So that question mark is, well, without the force. I already took the 4 to the n out. But let's look at this. So because I'm almost there, and notice I think I didn't put my 7, but all of these essentially we're going to do times the 7. So I'll be sure to write the 7 at the end once we have our series. So we need to figure out what is this guy over here. So let's do some math. So it's going to be, we're going to factor out all the negatives, right? All these negatives we can take out. So I'm really going to have 1, 5, 9. If we take the negative out of this, this is negative, what's that, 1/4 plus n minus 1 essentially. And so same as we did before, right? Get a common denominator. So multiply top and bottom by 4. And so I'm going to have my negative out here, 1/4 plus, and then 4n minus 4 over 4. And now I can add them. So they have a common denominator. And on the top, I'm left with 1 plus 4n minus 4, which is negative 4n minus 3 over 4. So that's just this part. With the negative, I took the negative out. And I factored the negative because I'm going to take out the minus from all of these. So now that I know that coefficient, that's that p minus n minus 1. So that's this guy, p minus n minus 1. So now we can write it all together. So therefore, right, my 7, 1 plus x to the negative 1/4 is going to be equal to, let me give myself a little more room. Let me write it down here. It's going to be equal to, well, we have our first, I'm going to write the first two terms. So 1 minus 1/4 x, I guess 3 terms. And then minus and minus, so that's plus, all right, let me write it this way. Minus 1 square, and then 1 times 5, right? Taking out the negative x squared over 2 factorial. So that's what I want to do. I want to take out the negative from all of these. So now plus dot, dot, dot. I forgot my 7 again. 7 times. This is the stuff that's in there. Plus, and so now the nth term. So what is my nth term going to look like? If I take the negative from all of these, I'm going to have, let's see, when I have x squared, I have 1, 2 negatives. When I have cube, I have 1, 2, 3 negatives in 4 to the third, right? And so that means that this is going to be minus 1 to the n times, and on the bottom, we're going to have our 4 to the n. Forgot my 4 squared here. And so the top now is 1 times 5 times 9 times 13 times dot, 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 right? I took the negative out. And when I took my negative out, this is what I end up with. Then times 4n minus 3, and then x to the n over n factorial. And this keeps going on forever. So this is, just to bring it back, right? So that's my p, well, I took the negative out. My p minus 1, p minus 2, p minus 3, and so on. And this is my p minus n minus 1. And so that is it. So therefore, what I'm going to do in the summation notation, my function 7 over 1 plus x to the 1/4, which is the fourth root, is equal to the summation from n equals 0 to infinity of 4 to the n over here, and then minus 1 to the n, then times 1 times 5 times 13 times dot 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 times 4n minus 3 x to the n over n factorial. So just like as before, right, the goal is to find the nth term. And so use, you can write some values just to kind of be able to see a pattern again, and then go for the nth one. So you're going to have your p minus 1, p minus 2, depending what p is. Our p here was minus 1/4. And then this is the tricky one, the p minus parentheses n minus 1. And that's your coefficient of the x to the n over n. So once you figure out that term, then you put it all together, and that's your summation, right? In short, this is really p choose n x to the n, but I noticed that in the book they want you to expand it. So this is what it means, expanding. List a few terms and find the nth one. All right, so hopefully that is helpful. Email me if you have any questions.